Anyone solved question 23? I think Siddhant solved.
Sorry, which one?
23.
So one second, let me check.
Yeah, you can check. So what are the masses? Prashantha, tell me. So masses are audible to you. Hello, hello.
Yes,
hello.
sir.
What are the masses? Mass is given how much?
So 300 grams and 600 grams.
So in such questions, it's good to say m and 2m, right? Because
Yes, sir.
acceleration depends on the mass ratio. So once you know the ratio, it's easy. Okay. So what is the acceleration here? If you draw the FBD, you know the answer. The net pulling force upon total mass. Correct. So with this acceleration, it will move down and it will move up. So what will be the velocity after 2 seconds? And which block you stop? 600 or 300? Yeah, M or 2M, tell me.
So 2m.
So when you stop something, its velocity will become 0.
0. Yeah.
And that M will try to move slightly up because of inertia. So tension becomes 0. Why? Because the tension will be, the string will slack. So the moment you stop, because of the velocity of the smaller mass M, it will try to go up. And the moment it will try to go up, string will slack. And because of that, there is no tension. So it's a free fall motion or motion under gravity because there is no tension force acting. So the idea is simple. Once you again stop and release, the 2m will start free falling downward and m will start free falling upward because of initial velocity. And the string will be taut when the distance traveled by the 2m mass in the free fall and the distance traveled by the m mass in the upward direction, both are equal. So once you travel equal distance, then again the string will be.
So why do we equate the distances and not the velocity?
Because the velocity can be equal, even the slack is there. I mean, tension is not there, isn't it? That's quite possible. So someone is starting from some initial velocity and someone is starting from the 0 velocity. So it is like we have thrown something up with the speed, let's say v, and something we have released from rest. So equal velocity will not guarantee that it will have equal, it will have tension, because see, let's say after some time it is gt and this is v minus gt. If you equate the velocity, it means after some time, let's say this is equal to this, then can we say that string is taut? Do we have any idea string is taut or not?
No.
So to keep the string taut, the length of the string is constant. So what you stretch and what you kind of slacken, so the left mass will try to shrink it and the right will try to expand it. So we have to equate the length so that the string is going back to the taut position, or full length is under tension. So that's why we write the distance, not the. So the m mass will go up. So M mass will have the initial velocity V, so it will go up by Vt minus half gt square. That's the displacement in the time t, upward direction. And 2m will go downward with free fall half gt square. Then once you equate, your job is done. So yeah, we're done. So this is t is, which is 2 by 3 second, right? This is the answer. Is this clear?
Yes.
Okay. So which other question?
So 15.
15. So 15 I explained you still you didn't solve.
So sorry, sir, I solved the
Yeah.
question.
The next only two.
Yes, sir.
The rest should solve
Sir,
each and every question. Yeah, Siddhant, tell me.
Yes, sir.
Sir, I have 2 doubts from the assignment which you gave.
Yeah.
Laws of motion.
Just a minute. So from S1, no doubt.
No, sir.
Prasansa, you have no doubt.
No, sir, no more doubts.
So you are sure that you have solved each and every question without skipping any question?
Yes, sir.
Very good. Excellent. Yeah. So now let me open this the sheet part. Just a minute. Yeah, Siddhant, tell me question.
Sir, the 18th one.
Page number?
So the PDF page number is 3.
Okay. Page number 3. How it is 3?
So a ring of mass M.
No, page number? How much?
So, so here the page number is not written.
At the
So
bottom.
that cam scanner one.
Okay, cam. Okay. Sorry. So you're asking the cam. Okay, laws of motion assignment, right?
Yes, sir.
Okay. All right. Just a minute. Yeah. Now I can see. A ring of mass M moves from point 1 to 2 along the smooth, rigid, horizontal wire with a constant speed v. The average force acting on the ring over the time of its motion. So what is the definition of average force? If someone will ask you, tell me. What is average force? Because unless you don't know the definition, you can't solve it. Tell me. What is the average force definition? Everything we have two definitions, average and instantaneous. So what is the definition of force from the Newton's law? How you define mathematically? Siddhant, I'm asking you only.
Yes, sir. So definition of force.
Huh.
So force is an external agent which can change
No,
the
not
state.
that definition. What is the mathematical definition?
So mass into acceleration.
No, that's not definition. What is the Newton's second law?
So the momentum one.
Yeah, what's the mathematical definition? The second law, what second law says?
Force is equal to the rate of change of momentum.
So rate of change of momentum, that's if you write F equals to dp by dt, this is called instantaneous. So what is the average force? Whenever you try to find something average, what do you do? So you are clueless, huh? You simply find the changing momentum, you divide by the time, that's it. That's the definition.
Okay, sir.
So to find the average force modulus, take the modulus of changing momentum and divide by the time in which you complete this motion. So do you know how to find the change momentum? Any idea?
Yes, sir. Initial
Do it
final
and tell me the
velocity.
answer. And we have done this in vector a lot. A lot of question of changing momentum we have done, changing velocity we have done, changing like find the displacement we have done. So all these questions are done somewhere. The problem is you never realize. And the definition of average and instantaneous should be very clear.
Yes, I got.
So what is the answer you're getting? Tell me.
Sir, final answer 2 mv square sin theta by 2 by theta.
Correct. So C option. So it is basically mv square by r into sine. It's like this in a nice way. And we have done all such questions in past. Okay. Any other doubt?
Yes, sir. The 31st.
31st. A block of mass M hangs from a rigid support by an ideal spring of stiffness K. If we pull the midpoint of the spring by distance x downward, okay. Sorry, this is 31st. Okay. If we pull the midpoint of the spring by a distance x downwards and release, the maximum speed of the block is. So our spring is massless. Okay. And what you're doing is because you're pulling the upper half, you can just draw two spring like this. So this is K. If you cut into two pieces halfway, it is 2K and this is 2K. So when you cut a spring, then the stiffness becomes double.
Yes.
Now, the elongation in the bottom one is due to the weight only.
Yes.
So this we can say x naught, and this is x. Okay. So here the x naught is how much already? It is 2K. X naught equals to mg, because that is sufficient. And also, okay, that is balanced. And now we suddenly release the system. Okay, this is something interesting. No, it is already balanced. Okay, okay. I think it doesn't matter whether the people at the midpoint or the end, it will be same. So the total energy stored. Wait. So let x not be the initial elongation. So we should not take this way. In the very beginning, both will have the half of elongation, because in the beginning, if I divide into two equal parts, then we can assume that the total deformation will be equally contributed, right? So x naught by 2 is here and x naught by 2 is there. Yeah, that's correct. Now, when you pull the midpoint, so this is the initial value, and now you pull the midpoint by 3x. So if you do so, the lower half will not suffer anything. It will just go down. I'm holding here. And okay, okay. So the total elongation, it's the same thing, I think. It's okay. This will not affect, but this is not from the logo motion directly. This is from the energy conservation. Okay, so here, okay, no matter where you pull the spring, the elongation will be for the entire spring only. So even if the moment you pull and release, it will rearrange itself in no time. And the deformation will be for the entire spring. And it will actually accelerate upward, right? So what is the acceleration of the block? So in the very beginning, you can write here like this. The total elongation is mg. So the at equilibrium, kx not equals to mg. So you can, okay, this is not required, but as a beginner, we should write equation 1. And now what you do is, so when you elongate further, what will happen? The net force will be more than before, isn't it? So spring force will become bigger than gravity. So now the force acting will be k times x plus x naught, because x naught was the initial and you pulled it by x. This is mg. And because kx naught is balancing mg, so anything more than kx naught will pull it upward, right? So what is the acceleration? Tell me. So acceleration will be kx plus x naught minus mg by m. Is this clear?
Yes.
And this will become how much? Kx plus kx naught minus mg by m. But this will cancel out. These two, do you realize this? Why? Since kx naught was equal to mg due to equilibrium condition.
Yes, sir.
And therefore the A turns out to be kx by m. Okay. And now we can write this is vd by dx, because A is a function of x. So we know from kinematics that whenever acceleration is variable, we have to write the differential equation. And we can only solve using the calculus. So when x is 0, it is 0. When x is x, I mean, if you go back to, actually, when you go back to the mean position, your velocity will be maximum. So this is the concept of anyway a system. But what you can realize that the maximum velocity occurs when you cross your point of equilibrium because of many reasons. So as of now, you can just start V max square by 2 is K by M x square by 2. And you can derive this. Okay.
Fine, sir.
Next.
So the 30th question.
30, the before question.
Yes, sir.
In the question number 29, if the smooth plank is free to move, the acceleration of the plank at a given instant is. Okay, okay. So a smooth block fitted with an ideal spring is, you got the question number 29? Answer?
Yes, sir. But I didn't solve. I just used a little.
Okay.
I used observation and then I got the answer.
Okay, okay. No, so let me show you how to solve exactly. So spring problems are generally a bit confusing. No need to worry. So a smooth block fitted with an ideal spring is pulled with an acceleration A. So if you pull with an acceleration A, okay, then in the frame of plank, draw the ABD of the block. So in frame of plank, ABD of block. So block is at rest in the frame of the plank, but the block is supposed to experience the pseudo force, and therefore to remain at rest in the frame of the plank, it must be experiencing some spring force. Let's call XKX force. So it means the spring must be under some elongation. Okay.
Yes.
So how much is the spring force acting here? MA only, right? Numerically. So we know
Yes.
it's a MA. Okay. So that's why it's accelerating and things are going like this. Now the moment you suddenly stop the plank and release, what does it mean? The A has gone. There is no A now, correct? But as we know, spring force will not vanish immediately. Spring force will not vanish immediately, which means it will be still acting. And if the spring is under elongation, so it will be pulling the both ends. But if you only draw the ABD of the plank as we are looking for, the force only acting is KX. Other forces will be gravity, but all are vertical. The only horizontal force acting on the Plank is how much? Can you see? What is the force acting on the plank? So if you draw the ABD, the only force acting on the plank is Kx, isn't it?
Yes, sir.
So what is the acceleration of the plank? The net force upon mass in the minus I direction, isn't it? But Kx is itself is how much? Hello. Do you realize this what I'm
Yes, sir.
saying?
Yes, I got it.
So the answer will be MA by M into minus I cap. I think B option is there.
Fine, sir.
So they're asking what is the acceleration of the block. So block acceleration will be A only. So for block, if you look at the previous question, for question number 29, if you draw the ABD of the block, so sorry, the force is again Kx. So A equals to Kx by M in the I direction because force is this thing. But Kx itself is M. So the A vector is
Yes. Fine.
understood how to attempt.
Yes, sir.
Next.
Done, sir.
Okay. It is clear to you, Prashansa?
Yes, sir.
Whenever you have two masses connected by a spring, then you have to draw the ABD as per the situation. And when you draw the ABD, detach the mass and then draw the ABD. Spring force will become external force for the individual mass, and the spring force will become internal force for the system. So if you say what is the force acting on the system, it is zero because spring is the internal force. So for individual acceleration, the spring force is external, but for the acceleration of a system, which you will come across in the chapter of center of mass, the spring force is internal, and therefore the acceleration of system will be zero. That's interesting. Understood what I'm saying? Okay, no, don't do that. So did you attempt question from the resonance sheet which I shared?
Yes, sir.
Siddhant, which topic is solved from the radio sheet? All questions?
No, sir, I have not attempted all, but just done.
Exercise 1 done.
So once again, I'll just tell you.
Okay, so everyone open the sheet. Okay. Go to page number 20. Or go to page number 19. Okay. Now solve the question number 2 and 3. Page 20. Do it quickly. Okay, solve, Siddhant.
The second one I've solved. I'm on the third one.
Prashantha.
Sir, I'm solving the second one.
Second one. Okay, question number 2, right?
Yes, sir.
No, do it fast. Do it fast. Think fast. See, you have to develop this fast thinking in laws of motion. You should
Sir,
see
I
all the
actually
evidence.
did a calculation error, so I'm doing it again.
No, that error is not acceptable. You have to just check what is the net force and how it can go right, left, or whatever. And they have mentioned something that which one is bigger. So F1 by M1 is less than F2 by M2, right? So, okay. So, read the question and you can attempt accordingly. This is too much time you have taken already. Done.
Yes, sir, done.
Okay, so let me see. So for the question number 2, what is given to you is F1 by M1 is less than F2 by. So this is oh, what is happening? This is given, right? All right. And what we are supposed to find? Tension and normal. Okay, so the first 2 questions will ask you the tension. So because F2 by M2 is more, so it will go towards right? So assume there is no tension. So the thing is simple. If you assume there is no tension, how the system will go? So F2 is bigger. F2 by M2 is bigger than F1 by M1. So it will go more towards right and less towards left with less acceleration, which means the entire system will go towards right. That's the whole idea. So the rule is simple. First, you assume the internal force to be 0 to check the net direction of motion of system. So that will take away the confusion, because if you are applying force here F2, and if you are applying force F1 here, and if you ignore tension for some time, then which one is accelerating faster, the M1 or M2?
M2.
Correct, because M2 is accelerating faster, so it means the system will go faster on right and slower on left, and therefore the net displacement of system will be towards right. And therefore, to solve this question, you may connect a string and you can assume some tension T here. And because of this constant, both will go towards right with the same acceleration A. So what is the A of system? You can clearly see A will be F2 minus F1. Correct?
Yes, sir.
And therefore, because this is the A of the system, you can get the tension easily by writing a body of any one of the block. So F2 minus T is M2 into A. And A itself is this much. Now, see, even you though doesn't understand which direction is right or left, how it will move, it actually doesn't matter. You can just choose any direction and solve it. You'll get the answer. The only difference will be the sign of the answer, the plus or minus. So technically, you should not worry about direction. If you can understand, it's really good, but it doesn't matter. But why it is given? Because I'll tell you the shortcut. Let's take the LCM. I hope you can see the answer, but to write in a manner which is very interesting. You can take because this is something like a reduced mass which will come across. And because I am taking M1, M2, so I will divide by M1, M2. And so it will look nicer. And now you can say this is like a reduced mass, and this is so you have seen a long way of solving. And the method 2 is, so in a 2-block system, the tension we can directly write as mu into A relative. That's it. So because this is the only force acting between the blocks, so you can directly use the formula as a you can call it trick, but it's a derivable trick actually. So it is always mu into A relative, and to find the A relative, we ignore the tension and we check how it will accelerate. Oh, this is. So if I think again as independent masses, so both would have accelerated in opposite direction. So M2 will accelerate this way and M1 will accelerate this way. What is the A relative here? You can clearly see it is the sum of acceleration. And therefore the acceleration is F1 by M1, assuming it's a independent. And therefore the internal force we can write this way. So the internal force will be like this, and this you can simply write mu is equal to reduced mass, if you remember. And the reduced mass is the product of mass upon summation. And A relative can simply write as the way we got there. So definitely you can solve with ease. And why it comes? I mean, of course, for any 2-mass system, this is what you will get even after solving, or without solving also you can get the answer if you simply know this simple trick. And it is applicable for all questions. So in the rest part of the question, you can do it directly. But in the option B, you can clearly see both will accelerate in the right direction, isn't it? Hello, hello, hello.
Yes.
If I ignore the tension, then both block will accelerate towards the right.
Yes.
And therefore the A relative will be how much? You know, A2 is more than A1, so it's A2 minus A1, right? And so the answer is F2 by M2 minus F1 by M1. And so the tension we can directly write as so tension we can write as reduced mass into A relative. Okay. I'll put this trick in a bracket. So over the time, I think you won't be able to remember. But if you keep on revising, it is easy. Okay. Similarly, for the option C, If we ignore the internal force, the one will accelerate right, two will accelerate left. So what is A relative again? So again, if you do the same thing, you'll get a similar answer, but let's do it anyway. So the acceleration we can write as from the basic, we can draw a body of each F1, and this is the normal, and the same normal will act on M2. And because F2 by M2 will have bigger acceleration, so it will try to go left. So both will have the acceleration left. So what we can write is the A of the system we can write as the net force upon net mass. And N equals to, okay, we can't write N directly. So to get N, we have to write the ability of anyone. So N minus F1 equals to M1A, or you can choose F2 minus N equals to M2A. And in this way, you can solve the problem. So N turns out to be F1 plus M1. That's interesting. So N is how much? And you can see it's a similar answer, right? Which you can write as mu times F1 by M1 plus. So you could have written this directly, which is same as mu into A relative. And if you look at the A relative is, so there are only two answers for each case. So the answer will be R for some cases and Q. Q and R are only answer for all cases. Is this clear, guys? Not clear?
Yes, sir.
So for D part, you can clearly see both will accelerate left. So what is the A relative? You can clearly see F2 by M2 minus F1 by M1, correct? Do you realize this? So the N is, and we're done. So it is easy one. And you know what to answer and how to answer. For A, it is which option? B, R, C, D. I think this is answer, right? Similarly, can you solve the question number 3? Not similarly, it's a different, but try to apply the concept. Don't try to get confused by the diagram. Just draw the FBD and think about it.
So I was getting the second part as Q.
Second part is Q for all answer.
No, the second part I was getting as Q, but the answer was R.
For second part, it is R only, no? Second part, I mean, you're saying the option B.
Yeah, but I am not getting where I did the error.
No, there is nothing there. See, in B, both will have access in the same direction.
Yeah.
So what is the A relative? The difference of the sum.
So I didn't do by the A relative method.
Okay.
So should I send
So
you the solution?
yeah, send. You just draw the ABD, you will get the right answer. F2 minus T equals to M2, T minus F1 equals to M1, F2 is equals to M2 is correct. This is correct. Yes. Oh my God. So your equation is wrong. It is T plus F1 equals to M, right? Can you check? The T and F1 is acting in the same direction.
Oh yes, so sorry.
Yeah. Anyway. Okay, Siddhant, tell me the third part, like third question you did. The
Yes.
spring pulley. So whenever there is a pulley attached to a spring, then the tension in the string and the other side will be equal. So, okay. So for A part, first of all, block is at rest. So tension in the lower string will be how much? Mg.
Yes, I'm sure.
So tension in the upper string will be 2 mg. And then we write 2 mg equals to kx, we will get x equals to 2 mg by k. Simple.
Yes.
In the B part, the tension itself is mg by k. Okay. And what there? And then what is this? And for the C and D part, you have to find the tension. So first you find the simply write the equilibrium of the lower block. So for the C part, T equals to mg, and for D part, T equals to 2 mg. That's it. What is there in the question? So tension is balancing the entire weight hanging from there, right? Tension will balance everything which is hanging from it. So for the C part, the hanging thing is only one mass, right? Mg. But for D part, the hanging part is 2m. Do you realize this? We have done all this.
Yes.
Go to page number 22 and solve question number 1, 2, 3, 4, 5, 6, 7, 8. 1 to 8. Solve. Keep on solving. You solve the exercise 1, then only I'll go to the next chapter. Unless you're not solving 100 to 200 questions of laws of motion, you will never get the idea of problems. Unless you're not pro with writing a question, you have to be pro. Like most of the questions should create the picture in your brain itself. All ABD should be very clear in your mind. Okay, you all started?
Yes.
Okay. So solve all questions like 1 to 8. The rest we have done as a constraint, but now I have to go beyond the constraint and solve questions. Part 2 is the testing round where you can test your skill to a greater extent. Won't be very easy. And then part 3 will be a bit of only ideas, not very difficult, but conceptual. The part 4 is really nice question here. These are good collection of questions. So once you're done with the exercise 2, repeat once or twice the entire exercise till you feel yourself confident with the concept. So don't be happy because you have solved. Be happy only when you have realized that what you are doing. So only when you feel that, okay, now I have a good command over the laws of motion, you can actually excel in physics with ease. I mean, physics won't be that difficult again. And every day we are spending in laws of motion, we have to cut from other chapters. So if you finish early, then you will get more chance to see the similar detail of other chapters. In the third question, it's very simple. Like when something moves with the same acceleration, you can think as a one system, and then the acceleration is net force on the system upon net mass of the system. So that idea you have to always carry. Do you realize this? So tell me, persons, are you able to now write the laws of motion equation with ease?
Yes, sir.
Okay. And do you feel that, okay, I can solve any question?
So I feel a bit more practice. And
Yeah. So are you ready for the practice? Because you do have to give a lot of practice here. It's not a regular study. You know, the problem is the way you prepare for boards, the thing which you did in the board preparation, that method is very redundant in JEE preparation. You have to live in the school itself. So it is not like a small syllabus which you can revise again and again. The way JEE preparation is done, you understand something to an extent that the revision is not at all required. You just realize everything. So don't think that it's a small syllabus which you can revise again and again as you wish. In fact, in the entire preparation, you won't get time to even see the chapter again. So it's so much of syllabus. So one has to devise a way not to, go back to each chapter. And this is possible in physics and maths mostly. In chemistry, you have to revise for sure because there are many information along with the concept, along with the context. So chemistry is a bit more demanding in that way. Physics, like once you understand one chapter, hopefully you're not supposed to see it again. I mean, that's good enough. You can always derive things from scratch, draw the ABD, write the laws of motion, and get your things done. And then what you need is a little bit of practice every day. And once you command mechanics, then you automatically become very good in physics. So those portion is having lots of theory actually. But when it comes to numerical solving, it is again the laws of motion you will see in those chapters, whether it's a magnetism or EMI, AC, everywhere there is a only laws of motion. So that's why it's important. Okay. Siddhant, you got the question of fourth?
So just started.
Okay. So in fourth, it's a very simple, it's a very interesting also. Cut it at the center, at the midpoint, and draw the ABD of half part. Okay. What they're asking, by the way? Ah, that's easy. They're asking the tension out of the chain at the end point. So that's easy. So the net vertical component is balancing the weight of the entire chain. There's also a very famous question. What is the tension at the bottommost point? So that's another question that you can create over it. Okay, how many done? Siddhant?
Sir, on the sixth one.
6 one, very good. Prashant sir, how many? Which question you're on?
So we're finishing fifth one.
Okay, great. So in the fifth one, you have to write the equilibrium for two masses separately and then you get the answer. Balancing the vertical forces, horizontal forces, and so on. You have to write things, as much as possible in the mind itself, like not taking time to draw ABD. ABDs are generally drawn in the brain itself, like when you practice a lot. And then you write the equation only. So that's how we become faster in solving problem. Okay, so for section, it's a very unique problem. It is having the multiple inclination, right? So let me draw first, then you can understand better. So first you can realize that there is a inclined plane. So this plane itself is inclined. And this angle is theta, right? And now on the plane itself, we have another groove. Actually, this is called groove. You cut a groove. So then you cut a groove like this. Okay. But it doesn't matter. All these diagrams of no use. So what you're supposed to remember? The diagram? No. And then this is another right angle triangle. In the plane itself, this is 3, this is 4. So you know this angle we can easily calculate. Let's call alpha. Now, if something is kept over the plane, so gravity will act downward, right? So you can see here, the mg or the gravity will act like this. So what is the component of gravity along the plane? So the component of gravity along the plane, we know the answer. This is g sine theta. Do you remember?
Yes, sir.
And this is just like a vector equation, just at the laws of motion. So this, if you go to the plane, this is g sine theta actually. This is not the, and now once you get the g sine theta, then no need to worry about the other component because that is going to be perpendicular. So once we are done with g sine theta, then we have to find this component because we have to take the g sine theta's component in the path of groove, okay, in this direction. So this is again simple. This is 90 minus alpha. So component of g sine theta will be how much? G sine theta sine alpha. Do you realize this? Okay. Hello.
Yes, sir.
So with this acceleration only you can accelerate in the groove. Okay. And because we know the acceleration along the groove and we know the path length, let's call L, which we can find it's 5 actually. So we can write as L equals to, or so if you release something from rest here, it will accelerate with this acceleration, and when it will reach the bottom, you can add the V square equals to U square plus 2AS, which is L here. V will want to know U is 0. And A we got, which is G sine theta sine alpha into L. That's it. So the speed of the ball at the bottom will be 2GL sine theta sine alpha. Everything is known to us. 2 into G is 10, L is 5. I think theta is 30 degrees, so which is half, and alpha is sine alpha is 4/5. Okay, so I think everything is clear. 5 gets cancelled, 2 gets cancelled. So the answer is 2√10 or √40. Is this clear?
Yes, sir.
So how to solve question? You just go to the plane and take the gravity component in that plane, and again think as a new world, a new gravitational world in which the G is having that value, and then you solve normally. So let's say you can in fact create some more question like this. So if I take a plane like this, okay, similar to what we did, and then I set up my Atwood machine by putting a pulley here. So now I'm setting up my Atwood machine here on the plane itself. This looks nice. So now the setup is here in the plane itself. So block can only slide down the plane or up the plane, and then so you attach some flat object like some striker or something, whatever, up to your creativity, doesn't matter. So maybe I take a thick sheet of iron, maybe like this, of mass M1 and M2. And if I say one is M1, other is M2, and the gravitational G is like this. So what will be the acceleration of the block? What will be A here? So in the plane of this surface, the G will change to G sin theta. So you can call this as G effective, the net G which you can expect here. And then you're not supposed to even go back and solve. We know the answer of G is a difference of mass upon sum of mass. The only difference is the G is replaced by G effective. That's it. Is this clear? And not only that, the tension, the way you write it is going to be same. 2m1 m2 by m1 plus m2, if you remember, into G effective. That's it. Everything will change that way. So laws of motion is same. The only thing which you need to realize is that let's replace the G by this G sin theta, because the pull force is not due to the mg, but mg sin theta is the only pull force acting there. So if you want to draw the FBD, you are most welcome. You can draw it. So that's why I say ideas are important. I mean, if you go into the numericals, you can create thousands of numerical with single idea. And every question we are not supposed to solve. We just should know the basic, and then we do it. Net force equals to mass into acceleration. Is this clear? Hello, hello, hello.
Yes, sir.
Yes.
Okay. All right. So do the next. 17 you can do. It's interesting. It's a question of kinematics from laws of motion. All are unique ideas. Like once you solve one question, you get a lot of idea that how to deal with question. And when you develop ideas, your own ideas, not what is said by teacher, you practice enough to create your own ideas. That's very important. So for 17, I'll just show you anyone. You can get from there. This angle is how much? 60 degree, right? And the acceleration will be g cos 60. So that's called A1. The other one is how much? This is A2, right? So to find the relative acceleration, it's simply you can draw both the diagram at the same point. So if I draw a vertical line as a reference, because that's a easy one, and you can clearly see that A1 is A2 is this way, and this is 20, and A2 is this way, right? Sorry, A1 is this way. Now this is also 30 because the net is 60. Am I right? So now we have A1, A2. How to find the A relative? It is always the difference in vector, right? So you can write A1 minus A2 or A2 minus 1 doesn't matter. What is the modulus of a relative? And we have done this in vector. How to find the difference of two vectors? So it's a formula is simple. A1 is square plus A2 is square minus 2 A1 A2 into cos of angle between the vectors. Okay. So what is A1 value? It is G by 2. What is A2? It is root 3 G by 2. So A1 is square, A2 square. So I can think G we can take common. So what we're left with is only coefficient 1 by 4 plus 3 by 4 minus 2 into 1 by 2 into 3 by 2 and cos 30 because that's the theta here. So root 3 by 2. This looks better. G 1 by 4 plus 3 by 4 is 1. 2 gets cancelled. So it's a 1 minus 3 by 4, which is right. This clear? Hello, 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 hello.
Yes, sir.
So G by 2 in the vertical direction? Yes. So to find the difference of two vectors, you have to reverse one of them. So if this is A1 vector, so this will be minus A1 vector. Like this. So this is if this is A1 vector, then if this is A1 vector, this is minus A1 and so quite possible it is vertical coming. So if you kind of draw the parallelogram, difficult to realize, but from vector we can realize. This is the resultant of the two. So actually, if you resolve, you can see that a horizontal component will cancel out and only vertical will sustain. So that's why when you do in the I cap J cap format, you can see the reaction also without much effort. But this is, I know it's going to be vertically downward. So from the option also, the A is the. Now your homework is to solve this with I cap J cap. Okay. So you know how to write I cap. So how to write if I choose downward as the y direction and horizontal as the x, for both, it is convenient to you because the journey is downward, so it's convenient. The left and the bottom as x and y. And okay, I will not do further. So you're supposed to write A1, A2 in vector form. I hope you know how to write in vector form, right? So once you write in vector form, your job is easy. Write in vector form, then take the difference and your answer will be in terms of I cap and J cap, and then take the modulo. Okay. Modulus, I mean, not module. Is this clear?
Yes, sir.
Okay. So can you do the question was 18?